Okay, so this is section E3.4, which is polynomial and rational inequalities. What this is something that looks like, I don't know, ax squared plus bx plus c is greater than 0. Something like that, okay? We still solve and find the zeros just like we have been doing in Unit 3. But now, instead of just finding the zeros, remember how before in like 3.1, we would test the points to see if they're below or above the x-axis? We're going to do the same thing here, and then depending on our symbol, that tells us which intervals we want as our solution, okay? If we have a greater than or a greater than or equal to, we want the intervals where the y values are above the x-axis. Okay, if we have a less than or equal to, we want the intervals where the y values are below the x-axis. So I'm going to show you how to do that, how to test the intervals like we did before and that type of stuff. Here's our steps to solving. Okay, first thing we do is we get it into standard form, which is what I have written here. Okay, this is ax squared plus bx plus c, and then whatever symbol you have, maybe it's less than 0. Okay, it could be less than, greater than or equal to, less than or equal to. So we're just going to move all terms to one side so that we have everything on one side and zeros on the other. Now, if we happen to have a rational inequality, then we have to make sure we make it one term, meaning we need a common denominator and that kind of thing. Okay. So once we have everything on one side and it's just one piece, okay, and then 0 on the other side, then we find all the zeros, okay? Now, one thing that does make it different than the problems we did in E3.1 is we find all the zeros of both the numerator and the denominator, okay? So if we have a rational inequality, we need to know the zeros from the top and the zeros from the bottom, okay? Once we have those zeros, then we're just going to test all the intervals between all those zeros to see if their y values are above the x-axis or below the x-axis. Okay, and then we shade our answer accordingly. So if we want the greater than intervals, we would shade all the intervals where the y's are above the x-axis. If we want the less than intervals, we would shade all the intervals where our y values are below the x-axis, or our negative intervals. Okay, so I want to go ahead and put down here, okay, this is a big one that a lot of people mess up on. Something to remember is that zeros from the denominator cannot be included, in your solution. Remember, they are our extraneous solutions or our excluded values. Okay, so I'm just going to put it here. They are excluded values because they make, or let's just say they make it undefined. They make it undefined. Okay, remember, if we include a 0 from the denominator, what that means is if I take that value and plug it back in, it makes my denominator equal 0. And we can't have a 0 in the denominator of a fraction because that makes it undefined. Okay, so not only do we have to find our zeros, but whenever we find our zeros from the denominator, we can never include them. Meaning, zeros from the denominators, we will always use a parenthesis on, not a bracket, because brackets include, parentheses exclude. Okay, so I'm going to go ahead and just say that. Thus, always use parentheses on zeros from the denominator. Okay, and I'm going to just go ahead and highlight that. Always use parentheses on the zeros from the denominator. Very important. Okay, remember, we use parentheses to exclude that value and we use brackets to include that value. So if we have something like less than or equal to, or we have greater than or equal to, okay, we use brackets. right? Or we use a closed dot. If we have a strict inequality, meaning we have less than or greater than, then we use parentheses. Okay, so if we have that equal to bar, we use brackets. If we don't have the equal to bar, we use parentheses. However, regardless of our symbol, if the 0 came from the denominator, we always use parentheses, regardless. Okay? Okay, so let's go ahead and look at one. This first one, we do not have a denominator, which is good. Okay, we just have a nice polynomial inequality. And notice for this one, it's actually nice because it's already factored for us. So if it's already factored for us, all we have to do is find the zeros. Okay, so I'm going to go ahead and just say this one is already factored. So all we have to do is find the zeros. Find zeros. So to find the zeros, we set each one of these factors equal to 0 and solve. So that means x equals 0, x minus 1 equals 0, x minus 2 equals 0, or 2x plus 1 equals 0. And I just solve each of them. The first one's already solved, x equals 0. The second one, I move my 1 over, which gives me x equals 1. The next one, I move my 2 over, which gives me x equals 2. And the last one, I move my 1 over, which gives me 2x equals negative 1. And then I divide off that 2. So I get x equals negative 1/2, which means that my zeros for this polynomial inequality are 0, 1, 2, and negative 1/2. And I'm going to write them in order so that it helps me put them on the number line. So negative 1/2 comes first, and then 0, and then 1, and then 2. Okay, so those are my zeros. Excuse me. And I either use a bracket or a parenthesis. So notice I'm going to go ahead and say use brackets because our symbol, because we have a greater than or equal to. Okay, so notice because of this symbol right here, that tells me I'm going to use brackets because I have that equal to bar. So here I went ahead and wrote the intervals in, so we can go ahead and say our first 0 is negative 1/2, our next 0 is 0, our next 0 is 1, our next 0 is 2. So if you notice, I went ahead and wrote these intervals that correspond to the values between my zeros. So this first interval is negative infinity to negative 1/2, okay? And then between negative 1/2 and 0, and then between 0 and 1, and between 1 and 2, and between 2 to infinity. Okay, so those are my intervals. Now I need to choose a test point from each interval. So something less than negative 1/2 would be negative 1. Something between negative 1/2 and 0 would be negative 1/4. Negative 1/4. Something between 0 and 1, I'm going to pick 1/2. Something between 1 and 2, I'm going to pick 1.5. Okay? Or you can write that as 3/2, or you can write that as 1.5, whatever makes sense to you. And something larger than 2, I'm going to pick 3. So remember, whenever we tested our intervals before, all we do is plug those numbers back into our function and see what it equals. And if it equals a positive, we know it's above the x-axis. If it equals a negative, we know it's below. Now here, I don't actually care what the value is, what the y value is when I plug it in. I just want to know if it's positive or negative. So I did this table a little bit different. Notice these are the factors, right? I have x times x minus 1 times x minus 2 times 2x plus 1. So what I'm going to do is I'm just going to see each factor, would it be positive or negative when I plug in this value. Okay, so I'm going to start plugging in the test points. I'm going to start with negative 1, and I actually notice that there's a typo here. Notice these numbers over here, x minus 1, x minus 2, 2x plus 1, those represent my factors. Okay, I had a factor of x, I had a factor of x minus 1, and then I had a factor of x minus 2, but that factor was actually squared. So I'm going to go ahead and put the squared on there. I forgot to type it in. And then my last factor was 2x plus 1. Now I want to mention something about this x minus 2 being squared. Notice whatever I plug in for x, I'm going to do x minus 2. And then regardless if that's positive or negative, when I square it, it's going to end up positive. Okay, so I could go ahead and just put positives across the board here, because if I put -1 in there, -1 minus 2 is -3, which when squared is positive. When I plug in -1/4, -1/4 minus 2 is negative, but when I square it is positive, okay? So if you see that you have a squared factor, or a factor that's like to the 4th or to the 6th or any even multiplicity, no matter what we plug in, it should have a positive output, okay? But I'm going to go ahead and show you each one. So if I plug in -1, if I plug -1 in for x, that's going to be negative. If I plug -1 into my next factor, x minus 1, -1 minus 1 is -2, which is negative. We already talked about if we plug in -1 minus 2 is -3, but when we square it, it becomes positive. When I plug -1 into my last quantity, -1 times 2 is -2, plus 1 is negative. Okay, so what I would normally do when I plug in -1, I plug it into each of the factors, and then I multiply all those factors together. Now, I don't really care what the value is. I just want to know if it's going to be a positive or negative. So I do negative times negative is positive, times another positive is still positive, times a negative is going to be a negative interval, which means that for all these x's between -infinity and -1/2, our y values are going to be below the x-axis. Okay, so I want to do the same thing for this next interval. To represent between -1/2 and 0, we picked -1/4. When I plug -1/4 into x, that's going to be negative. -1/4 into my next factor, which is x minus 1. So -1/4 minus 1 is going to be negative. -1/4 minus 2 ends up being negative, but when I square it, it becomes positive. -1/4 into my last factor here, 2 times -1/4 is -1/2, plus 1 gives me positive 1/2, which is positive. Okay, so I'm going to multiply those 4 signs together. I have 2 negatives and 2 positives, which is going to make this a positive interval, which means that all my y values for this set of x's are above the x-axis. Okay, and then I'm going to do the same thing for the next 3. I'm going to go a little bit faster because I believe that y'all can plug in numbers and see if they're positive or negative. So when I plug in 1/2, that's positive. 1/2 minus 1 is negative. 1/2 minus 2 is negative, but when I square it, it becomes positive. 2 times 1/2 is 1, plus 1 is 2, which is positive. So when I multiply these together, excuse me, I have a positive and negative and 2 positives, which is going to be negative, which means that my y's are below the x-axis in this interval. Okay. When I plug in 1/2, that's positive. 1/2 minus 1 is positive. 1/2 minus 2 is negative, but then I square it, which makes it positive. 1/2 times 2 plus 1 is going to be positive. So this is a positive interval, which means that my values are above the x-axis. Okay, and then I do my last interval. 3 when I plug in is positive. 3 minus 1 is positive. 3 minus 2 is positive. Square it, still positive. And 2 times 3 plus 1 is positive. So this is a positive interval, which means that my y values are above the x-axis. Okay, so now that I know where my y's are located for each interval, are they above or below, now I have to determine my solution. So again, I look back at my symbol, which here is a greater than or equal to. Okay, so the sign I have here is greater than or equal to. Greater than or equal to tells me that I want the positive intervals. So I'm going to say want positive intervals. So the ones that we got a positive value for was this interval and these 2 intervals. So that means if I go up here and graph it, that means between -1/2 and 0, that's a solution. Between 1 and 2 is a solution, and from 2 on to infinity is a solution. Then I look back at what symbols I'm using. Because it's greater than or equal to, I'm including my endpoints. So I'm going to use a bracket here at -1/2. I'm going to use a bracket at 0. Okay, and then notice, excuse me, from 1 to 2, I can use a bracket on the 1, but I don't need to do double brackets at the 2. I'm including the 2, but since I have shading on each side of the 2, I'm just going to shade straight through the 2. Okay, you don't have to do double brackets. So what that tells me for my solution is, if I write interval notation, what is represented here by my purple shading is my solution is from negative 1/2 to 0, both with brackets, and then it picks up again at 1 with a bracket and goes on out to positive infinity. Okay, so we find our zeros, test in between our zeros to see if our y's are positive or negative, and then we look at our symbol. If it's a greater than symbol, we want the positive intervals. If it's a less than symbol, then we want the negative intervals. And we just shade accordingly and then express our solution in interval notation. Okay, let's look at another one. When we look at this next one, okay, this one again is not rational, meaning we don't have fractions, but it's not in standard form. To get it in standard form, I need to move everything to one side so that it's equal to 0. So I'm going to move my x and my 90 to the other side by adding x and subtracting 90. Whoops, and I picked a color that I wasn't using previously. Let's stick with the same color scheme. So plus x minus 90 plus x minus 90. So when everything's on one side, it looks like x squared plus x minus 90 is less than 0. Okay, now I need to find the zeros. So to find the zeros, I have 3 terms. My highest degree is squared, okay, which is 2. So I can try factoring, or I can use the quadratic formula. So I want to go ahead and see if I can factor this. To use sum product, my sum would be 1, my product would be negative 90. To get negative 90, I could use, let's see, 10 and 9, and I would need my 9 to be negative so that I can end up with a positive 1. Since my leading coefficient is a 1, I know that these are my factors, which tells me that this factors into x plus 10 times x minus 9, and then I just set each one equal to 0 and solve. So x plus 10 equals 0, x minus 9 equals 0, which gives me x is equal to negative 10, or x is equal to 9. Okay, so those are my zeros, so I'm going to go ahead and just write them here. My zeros are negative 10 and 9, and then I'm not going to include these zeros because my symbol is a strict less than. So I'm going to say use parentheses because I can't write because we have a less than. Okay, since there's no equal to bar, that means we're using parentheses at each 0. So notice I went ahead and gave you the chart. Our first 0 is negative 10. Our next 0 is 9. Okay, so that means my first interval would be from negative infinity to negative 10 with a parenthesis, because we're not including. Okay, and then from negative 10 to 9, and then from 9 to infinity. So I'm going to pick a test point in between each interval. So something less than negative 10, I'll pick negative 11. Something between negative 10 and 9 would be 0. Something bigger than 9 would be 10. And I'm going to plug those into my factors. So notice once we factored it, one of my factors was x plus 10. The other factor was x minus 9. So I just want to plug these in and see if I'm going to get a positive number or a negative number. When I plug negative 11 into x plus 10, okay, I end up with a negative 1, which is negative. When I plug negative 11 into x minus 9, I get negative 20, which is negative. And a negative times a negative is a positive, which means that my y values for this interval are above the x-axis. I'm going to do the same thing for 0. When I plug 0 in, I get a positive. When I plug 0 into my second factor, I get a negative. Positive times negative is negative, which means that my y values for this interval are below the x-axis. Okay. And then for 10, when I plug 10 in, I get a positive and a positive, which gives me a positive interval, which means my y values are above the x-axis. Okay. So again, I look back at my symbol. My symbol was a less than. So since we have a less than 0, this means we want the negative intervals. Okay, or we want the intervals that are below the x-axis. So the only one I have here that is below the x-axis is this one. Okay, so that means my solution is between negative 10 and 9. Again, it's a strict inequality, so we're using parentheses. We're not including the negative 10. We're not including the 9. So my solution here would be from negative 10 with a parenthesis to 9 with a parenthesis. Okay? Okay. Let me look at two more. I'm going to do two that are rational, and then I'll let y'all try some. So on this first one, we want it in standard form. Standard form means that all of our x's and constant terms, everything is on one side, and we just have 0 on the other side. So here, notice it's already in standard form, and the numerator and the denominator both are in descending order. So since I already have one term, I'm going to go ahead and find the zeros from the top and the zeros from the bottom. Okay, I do it separately. So I'm going to go ahead and say from the top, if I want to find my zeros, I'm going to set 2x squared minus 18x equal to 0 and solve. I'm going to go ahead and take out a greatest common factor, which would be 2x, which leaves me with x minus 9. And then if I set each of these equal to 0, excuse me, if I set each of these equal to 0, I get 2x equals 0, and I get x minus 9 equals 0. Which if I divide off 2 here, I get x equals 0, and if I move 9 to the other side, I get x equals 9. Okay, so my zeros from the top are 0 and 9. Okay, so I'm going to go ahead, well, I'll wait until I do the bottom ones. So I have 0 and 9, and I'm going to go ahead and put on these two factors. The factors from the top that I got is I had a 2x and I had an x minus 9. Now I want to find the zeros from the bottom. Okay, so from the bottom I have x squared minus 2x plus 1 equals 0. Notice if I factor this using sum product, I need a sum of negative 2 and a product of 1. The only way I can get a product of 1 is 1 times 1. And if I do a negative 1 times a negative 1, that will give me the positive 1. And negative 1 minus 1 gives me the negative 2 that I need. Which means that this factors into x minus 1 times x minus 1. Or we can write this as x minus 1 squared, right? And if I solve that x minus 1 equals 0, then I end up with x equals positive 1. So that's my other 0. And I'm going to go ahead and write my factor here from the bottom. Now the bottom actually factored into x minus 1 times x minus 1. But I'm going to write that as x minus 1 squared. Because just like before, remember we have a squared quantity, no matter what we plug in, it will always come out positive. So it saves us a little bit of time. Okay, so I'm going to go ahead and write out all my zeros. The zeros I got from the top was 0 and 9, and the 0 I got from the bottom was 1. So I'm going to go ahead and put my zeros up here. So 0 comes first, and then, whoops, 0, and then 1, and then 9. So my interval before I get to 0 would be negative infinity to 0. Now, let's think about this. My 0 came from the top. Okay, so I look at my symbol. Whenever I see this symbol, that tells me that I'm going to use brackets. Okay, but I can't use brackets on zeros that came from the denominator. So for this 0, x equals 1, I'm going to use parentheses because the denominator cannot equal 0. Okay, remember we always exclude the zeros from the denominator. So when I'm writing these out, I want to make sure I have them labeled right. So 0 came from the top. It's okay to have zeros on top, so I'm going to include that 0 with a bracket. Then I'm going to go from 0 to 1. Again, I can include 0 with a bracket. And then I'm going to go over to 1. And remember, 1 came from the bottom. So I have to use a parenthesis there. Okay. Again, on the other side of 1, I use a parenthesis. Over to 9, which 9 came from the top, so I can include it with a bracket. And then from 9 to infinity. Okay. So my symbol says to use brackets. So I use brackets on every 0 except those that came from the denominator, which in this case is a 1. So where I see my 1, I'm using parentheses instead of brackets. Okay. Now I'm going to go ahead and pick my test points. I'm going to pick negative 1 for my first interval. Something between 0 and 1, I'm going to pick 1/2. Something between 1 and 9, I'm going to pick 2. Something bigger than 9, I'm going to pick 10. Okay. And I'm just going to plug these into each factor. So 2 times negative 1 is negative. Negative 1 minus 9 is negative. And then this last one I know is going to end up positive, because no matter what I get when I plug it in, when I square it, it becomes positive. So I have 2 negatives and a positive, which gives me a positive interval, which means that my y's are above the x-axis. Okay. I want to do the same thing with 1/2. 2 times 1/2 is positive. 1/2 minus 9 is negative. And then my last one's going to be positive because it's a squared interval. In fact, I'm going to go ahead and just write positives in on down, because no matter what we plug in, it will be positive because we're squaring it. Okay. So here I have 2 positives and 1 negative, which gives me a negative interval, which means that my y's are going to be below the x-axis. When I plug in 2, that's going to give me a positive, and then 2 minus 9 is negative. Okay. So I have a negative here, so my y values are going to be below the x-axis. And then my last interval, I have 10. So 2 times 10 is positive, 10 minus 9 is positive. So I end up with a positive interval, which means my y's are above the x-axis. Okay. So then I go back to my symbol, remember, always go back to the symbol to see what solutions you want. When I go back to my symbol, this tells me that I have a less than or equal to, okay, which means that we want the negative, right? We want the negative intervals, or the intervals that are below the x-axis, okay, which is this interval and this interval. Okay, so I'm going to go up to my graph and I'm going to shade between 0 and 1 and shade between 1 and 9. Now, we have to pay close attention to our symbols. Okay, remember on 0 we can include it with a bracket, but at 1 we cannot include it. So even though the shading looks like it should go straight across 1, because we can't actually include that 1 value, then we're going to use parentheses on each side of the 1 to show we're taking that 1 out. Okay, and then it goes on over to 9 with a bracket. So that means my solution for this one, would be from 0 with a bracket to 1 with a parenthesis, and then it picks up again at 1 and goes on out to 9 with a bracket. Okay, so even though we shaded across both intervals, we can't include that 1 because that 1 came from the denominator, and we can't have 0 in the denominator. Okay. All right, let me look at one more rational example, and then I'll have y'all try some. Okay. All right, so this one, notice it's not in standard form. Everything's not on one side. So I'm going to go ahead and move my 16 over x minus 3 to the other side. And I do that just like any other term. I'm just going to subtract it. So that will give me 4x. When I move this 16 term, it's going to become negative. So I have negative 16 over x plus 3 is less than or equal to 0. So I'm just moving it to the other side. Now I need to go ahead and combine these. When I combine these, I need a common denominator. So I'm going to write this as 4x over 1. And here my common denominator would be x plus 3. So I'm going to go ahead and multiply this first one by x plus 3 on top and bottom so that I have that common denominator. So my new numerator here, 4x times x is 4x squared. 4x times 3 is 12x minus the 16 from the second term all over x plus 3. Okay. And then I'm going to combine the 12 and the 14. So I have 4x squared minus 4 all over x plus 3 is less than or equal to 0. Okay, so now I need to find my zeros from the top and my zeros from the bottom. So I'm going to look at the top. When I find my zeros from the top, I can take out a greatest common factor, which is 4. And I'm left with x squared minus 1. X squared minus 1 is a difference of squares. So that factors into x plus 1 times x minus 1. Okay. When I solve these, x plus 1 equals 0 or x minus 1 equals 0, I end up with x equals negative 1 or x equals positive 1. Okay. And then I'm going to go ahead and write out my factors. Now I had a greatest common factor of 4, which doesn't affect the sign, but I'm going to go ahead and write it in there just because it bothers people if I don't. So I'm going to put the 4 on the first factor, which was x plus 1. And then the next factor was x minus 1. Again, if you don't use the 4, it doesn't matter because we don't actually care what the y value is when we plug it in. We're looking just to see if it's going to be a positive y value or a negative y value. But just for the sake of being a little bit accurate, I'm going to leave the 4 in there. Okay. Now we need to find our zeros from the bottom. We look at our bottom, which is x plus 3 in our denominator. When I set that equal to 0, that gives us x equals negative 3. Okay, and that factor was x plus 3. Now, just like before, when I look at this symbol, okay, I have a less than or equal to. When I have a less than or equal to, this is telling me to use brackets because as an equal to bar, I am including that 0. Okay, but since I have a rational inequality, any zeros from the denominator have to be excluded. So for x equals negative 3, I'm going to use parentheses because the denominator cannot be 0. Okay, so the zeros that we ended up with were negative 1 and 1 from the top and negative 3 from the bottom. So I'm going to put negative 3 on here first, then negative 1, then 1. And I guess I should write that out. It's always a good idea to write out our zeros. Our zeros were negative 3, negative 1, and 1. Okay. So that means my first interval goes from negative infinity up to negative 3. Negative 3 came from the bottom, so I'm using a parenthesis on it. Okay. And again, my next interval is going to go from negative 3 to negative 1. I have to use a parenthesis on the negative 3 because it came from the bottom. Negative 1 came from the top, so I can use the bracket. Okay. Then negative 1 to 1 I can use a bracket, and 1 to infinity I can use a bracket. Okay. Only on the zeros from the denominator do you have to use parentheses. Okay. Or if it's a strict inequality, right? If it doesn't have the equal to bar to begin with, then you would use parentheses on everything. Okay, so let's pick some test points. So something smaller than negative 3 would be negative 4. Something between negative 3 and negative 1 would be negative 2. Something between negative 1 and 1, I'm going to pick 0. And something larger than 1, I'll pick 2. Okay, so I'm going to plug these in. When I plug in negative 4 plus 1 is going to be negative, times a positive 4 is still negative. Okay, negative 4 minus 1 is going to be negative. Okay, so when I plug negative 4 into x minus 3, that gives me negative. So 3 negatives makes this a negative interval, which means that my y values are going to be below the x-axis. Okay, when I plug negative 2 in, negative 2 plus 1 is negative, times a positive 4 is still negative. Negative 2 minus 1 is negative. Negative 2 plus 3 is positive. Okay, so 2 negatives and a positive make this a positive interval, which means my y values are going to be above the x-axis. Okay, when I plug 0 in, 0 plus 1 is 0, times 4 is 4, so that's positive. 0 minus 1 is negative. 0 plus 3 is positive. So this is going to be a negative interval, which means my y values are going to be below the x-axis. When I plug in 2, I'm going to get a positive, and a positive, which makes this a positive interval, which means that they are going to be above the x-axis. Okay, so I go back to my symbol. I look at my symbol. In this case, it is a less than or equal to. Less than or equal to 0 means that we want, oh my goodness, my hand is not doing what my brain tells it to. Less than or equal to means that we want the negative, okay, intervals, or the below the x-axis intervals. Okay, so below the x-axis would be this interval and this interval. So if I shade that on my graph, that would be from negative infinity up to negative 3, and then from negative 1 to positive 1. Make sure you use the correct symbols. Negative 3 came from the denominator, so it has to have a parenthesis. Negative 1 and 1 came from the numerator, so we can use brackets on those. Okay. So my solution for this rational inequality would be from negative infinity to negative 3 with a parenthesis, and then from negative 1 to 1 with a bracket. Okay? All right, so on the next couple of pages, there's some for y'all to try. I will tell you, I mixed up number 1 and number 2 I went ahead and put the chart in for you, and I switched the order of 1 and 2. So the charts don't match up with the problems. So before you start working these, go ahead and change the inequality given. So number 1 should be 2x minus 1 all over x squared plus 4x minus 5 is greater than or equal to 0. Okay, and then I'm going to move this one down to number 2. So number 2 should be what we had for number 1, which is x squared plus 4x is greater than 45. Okay, so we're just switching number 1 and number 2 so that the tables match the necessary or the given problem. Okay, number 3 is fine. So I'm going to give y'all a few minutes to go over, to work through the practice problems, and then we'll go over them. Okay? Okay, so on the first practice problem, we find our zeros from the top, which we just get 1, it's 1/2, and it's included because it's greater than or equal to 0. So next to the 1/2, I'm going to use a bracket. Okay, the zeros from the bottom, once we get it factored, should be 5 and -1. Okay, they both came from the bottom, which means they both have to use parentheses. Okay, so anywhere I see a -1 or a 5, I'm using parentheses. Anywhere I see a 1/2, I'm using the bracket. Okay, because this is a greater than or equal to, that means we want the positive intervals. Okay, positive intervals, when we test our points, should be from -1 to 1/2. 1 with a parenthesis, 1/2 with a bracket, and the other positive interval I end up with is 5 to infinity. 5 came from the bottom, so we use a parenthesis on it. Okay, so our solution should be from -1 to 1/2 and 5 to infinity. Make sure you get the correct symbols. Okay. Then I look at number 2. There's no denominator, just a numerator here, okay? So we move everything to one side to get it in standard form, and we factor it. When we factor it, we get zeros of -9 and 5, and they're not included because notice here we're using a strict greater than inequality, which means that we're going to use parentheses on all of our zeros. Okay, because it's a greater than, that means we want the positive intervals, or the intervals that are above the x-axis. So when we test our intervals, we're testing from -infinity to 9, 9 to 5, and 5 to infinity. Okay, so I picked some values here in pink. When I plug them in, we end up with 2 intervals that are above the x-axis, which is from -infinity to 9 and 5 to infinity. So that's my solution. Make sure you're using parentheses on all of it because we're using a strictly greater than symbol. Okay, and then the last one, we have to move the term over to the left and get a common denominator. So I move my 9 over x plus 2 to the other side, which makes it negative. And then I multiply my first term on top and bottom by x plus 2 so that it has the same denominator. When I distribute that 3x, I get 3x squared plus 6x minus the 9 from that second term all over x plus 2. I factor the top. I started by taking out a greatest common factor. And then my trinomial factors into x minus 1 times x plus 3, which gives me the two zeros, 1 and -3. Okay, and they're not included because this is a strictly less than. So notice, since it's a strictly less than, I don't even have to worry about what comes from the top and what comes from the bottom because I'm using parentheses on everything. Okay, so the zeros from the top are 1 and -3, and then notice from the bottom I have x plus 2, so that means my 0 is -2. Okay, so I went ahead and wrote my intervals from -infinity to -3, -3 to 2, -2 to 1, and 1 to infinity. I picked a pink test point for each one. Okay, and when I plug them in, and notice I went ahead and just stuck my greatest common factor here on the first factor. Since we're not actually finding the actual y value, the correct, accurate y value, we just want to know the sign of it. If you don't include that 3 here when you're testing your intervals, that's fine. But just for good form, I went ahead and put it in there just so that we do have a representation of the entire factored polynomial. So notice when I plug like -4 in here, -4 minus 1 is negative. If I multiply that by 3, it's still going to be negative. Okay? All right, so I end up with, since I want strictly less than 0, that means I want the negative intervals. The negative intervals are the ones where the y values are below the x-axis. So I have 2 intervals where it's below the x-axis, which is from -infinity to -3 and -2 to 1. So that's my solution. Make sure you're using parentheses on everything. Okay, so that is the end of section 3.4. 3.4 has a My Math Lab assignment. It also has a worksheet, which is located under the Course Materials tab of your My Math Lab homepage. If you have any questions, please let me know. And good luck.